So today we will learn about scheduling, how the process is scheduled. Since in multi operating in environment, when there are multiple programs that need to be taken care of, then operating system must switch between one process to another process so as to give enough time for all the processes for completion. It should not happen that only it is processing two processes and other processes are waiting. So process selection must be done very carefully so that each and every process gets proper time to execute. Also, for allocating the process to CPU and for executing all the processes at the same time, several algorithms need to be followed. Several algorithms are there. Soon we will learn about those algorithms. So let us first share my slide, share my screen, then we will start. Is my screen visible?
Yes, ma'am.
Okay. So my screen is visible to all. So today is the 7th class of operating system where we will learn CPU scheduling and FCFS. Now the question is that what is scheduling? Before looking into everything, before looking about or learning about CPU scheduling, what is schedule? Have you ever heard the word schedule before? In real life, have you ever heard the word schedule? If anyone have heard, unmute yourself.
Routine. Yes, ma'am.
And someone else? One said routine.
Routine. Hello, ma'am. Routine.
Routine. Okay. Routine means it can be termed as schedule also. Like
to
yes.
add something in a time.
I'm not able to listen.
To add in something in a particular time.
Yes, yes. Arrange something in a particular time. Just like in your timetable, there are different classes, first period, second period, third period. All the classes are held as per the schedule given by timetable committee. And if there is a change in class schedule, it means suppose English class will come or will be happen before Hindi class. Earlier it was after Hindi class. Now English class will be held before Hindi class. So this is schedule. How to arrange different processes in case of operating system. We can say how to arrange different process one after another. And before that, if we are talking about timetable, then scheduling means what subject will be taught in first period, in second period, in third period, and so on. So the process scheduling is the activity of the process manager that handles the removal of the running processes from the CPU and the selection of another process on the basis of a particular strategy. So this is the definition of process scheduling. Process scheduling is, we can say it is an essential part of, multi-programming operating system. Why it is an essential part? Because if there are several processes, only then multi-programming can be achieved. Else multi-programming could not be achieved with just one job. So it is the process of multi-programming operating system. Unless and until there are different programs, then CPU scheduling cannot be done. So it is the job of multi-programming operating system. So multi-programming operating systems allow more than one process to be loaded into the executable memory at a time, and the loaded process shares the CPU using time multiplexing. Just wait for a few minutes, then I will come back. Just wait for a few more minutes. I will then take the. Actually, today I am in college, so some of the MCA final year students came, as they don't have, they have not met their teachers for a long time. Also, this time we have given them online farewell, as all of you are aware. So they just came to meet me. I am in college only, so they just take one snap and then they went away. Their joining has been already been given. Some of them are joining. They get placed, like place campus placement. So they have come to college to collect their result. Okay, so let us come back to CPU scheduling. Process scheduling is an essential part of multi-programming operating system. Such operating systems allow more than one process to be loaded into the executable memory at a time, and the loaded process shares the CPU using time multiplexing. What is time multiplexing? Time multiplexing means division of time into small slices. Time is divided in small slices and the process scheduling is being done. Now let us go to next slide. CPU scheduling. CPU scheduling is of two types, preemptive and non-preemptive. I want to share my whiteboard with you. Is my whiteboard visible?
Yes, ma'am.
Yes, ma'am.
If we say scheduling, so scheduling is of two types. Just like you have seen, now I will draw again since there is something more I want to say. Non-preemptive and preemptive. These are, does anyone know the meaning of non-preemptive and preemptive? Anyone? Yes, Emily, unmute yourself and speak. You
না
want
ম্যাম এটা ভুল করে দিয়ে ফেলেছি
to ভুল করে
ভুল করে দিয়ে হ্যাঁ
আচ্ছা আচ্ছা ঠিক আছে, নো ইস্যু, নো ইস্যু। কেউ বলতে চাও what is preemptive scheduling and non-preemptive scheduling? Probably these terms are new. Wait. CPU completes the execution of the process and don't jump to any other process in between. This is non-preemptive. What is non-preemptive? Non-preemptive is CPU completes the execution of the process and don't jump to any other process in between. Now, if we look at preemptive, what does it mean? CPU jumps between the execution of processes. CPU jumps between the execution of process so as to provide service to all of them. So this is scheduling. Scheduling, preemptive scheduling and non-preemptive scheduling. In preemptive scheduling, CPU jumps between the execution of processes so as to provide services to all of them. And in case of non-preemptive scheduling, CPU completes the execution of process and don't jump to any other process. Wait. So this is the diagrammatic representation of CPU scheduling. Now, wait. We come back to the slide. Let us go back to the slide. Up to this, I don't think there is any confusion. If there is, then you can ask. And if you think it is necessary or it is useful, you can draw this diagram in your notebook also. So this is scheduling criteria. Maximize CPU utilization, throughput, minimize turnaround time, waiting time, and response time. This is the motto, or the we can say this is the scheduling criteria that we need to maximize CPU utilization. When there are different processes that want CPU time, then CPU utilization should be done at maximum. It means CPU should process all the processes, or CPU should provide service to all the processes. What is throughput? Does anyone have any idea about throughput? Anyone heard the term throughput? Throughput is a concept where the process will, it is the measure of CPU performance, and it gives, or it is the formal definition is the time the process is submitted in a queue till it completes its execution. That time is called throughput time. What is the requirement of a user? The user wants their program to be quick so as to complete the execution of the program in a fast manner. Whenever you use certain applications or you are opening any website, what do you want? Quick response.
Ma'am, your voice is not audible, ma'am.
My voice is not audible.
Ma'am, কেটে কেটে যাচ্ছে মাঝে মাঝে।
I think it is due to network problem. I am speaking at the top of my voice. All of you are able to view my screen or not?
Yes, ma'am. Yes.
ma'am.
Now I am again sharing the whiteboard and drawing one diagram of scheduling. Wait. There are different queues. This is job queue. Then there are different types of queues. Ready queue, ready queue, these are different types of queues which are used by, or which are used in scheduling process. And this is CPU. Okay. Then there is input output, sorry, input output or waiting queue. Then there is IO, input output. Okay. These are different views. Now let me draw. This is the diagram. Also, there is a connection also there is a connection from CPU to ready queue. It can be like this. Okay. There is one more text box I need to make that shows exit. This is the diagrammatic representation of scheduling. There are actually different queues that need to be maintained. The operating system maintains all the PCBs in process scheduling queues. The operating system maintains separate queue for each of the process state, and PCBs of all processes in the same execution states are placed in the same queue. When the state of a process is changed, its PCB is unlinked from its current queue. Process control block, which takes care of all the information, it is changed, or the detailing of the entry of the PCB is changed once the state of the process is changed. Maybe the process jumps between job queue to ready queue to IO waiting queue. Then the position in the process control block also changes. Now let us go back to the slide. These are the different scheduling types. FCFS, shortest job first, SJF or SRTF, preemptive and non-preemptive. Look, the same algorithm, SJF, shortest job first. There are two variations. One is preemptive and another is non-preemptive. Then priority and then round robin. These are different types of scheduling, but before going into that, let us again look at this diagram. Let us explain all these queues one by one. What are these queues? Job queue. This queue keeps all the processes in the system. Then ready queue. This queue keeps a set of all processes residing in main memory. Ready and residing in main memory, ready and waiting to execute. That means all the processes which are waiting to get executed resides in this memory. A new process is always put in the queue. Device queue or IO waiting queue, the processes which are blocked due to unavailability of an IO device, they are kept in IO waiting queue. Suppose some of the process, they are IO based. So IO waiting queue, they are kept in IO waiting queue. The operating system can use different policies to manage each queue. Each and every queue is managed by different policies like FIFO, round robin, priority. In the earlier slide, you have seen SJF. So these are the different policies. The OS scheduler determines how to move processes between the ready and run queues, which can only have one entry per processor core on the system. So this is the diagram. If we talk of the state of system, there are two states, running and not running. Running, when a process is created, it enters into the system as running state, and not running, processes that are not running are kept in queue. So let us go back to my slide. What are CPU scheduling parameters? These are different CPU scheduling parameters. CPU burst time, CPU utilization, waiting time, turnaround time, priority, throughput, load time, response time. These are different types of CPU scheduling parameters. Based on this parameter, which type of scheduling will be selected, these points are taken into, or these parameters are taken into consideration. Based on the process type, the scheduling will differ. Preemptive scheduling policies. In this type of policies, if suppose there is another process in the queue and that process wants to take or wants to enter into the queue, then the processing of the executing process is stopped and the control is being given to another process. A request may be scheduled many times before it is completed. Larger scheduling overheads than with non-preemptive scheduling. Why overhead? Because a track need to be maintained, which process is swapped out from the memory, which process is swapped in the queue. So these information need to be kept, which cause overhead. Overhead means you can say extra work or extra effort, which requires time as well as information also. Time as well as storage space. So preemptive scheduling policies is used in multi-programming and time-sharing operating system. Non-preemptive scheduling. Non-preemptive scheduling is used when a process terminates or a process switches from running to waiting state. In this scheduling, once the resource is allocated to a process, the process holds the CPU till it's get terminated, or it holds the CPU till it get terminated. Non-preemptive scheduling, in simple word, we can say that when a program or a process get control of execution for one particular process, then the process will execute at a whole from start to finish before giving the control to any other requesting processes. Okay, so let us go to scheduling criteria. This we have already seen. CPU utilization. It should be kept in mind that CPU should be as busy as possible. Like CPU utilization varies from 0 to 100%. The motto or the aims should be the CPU should remain as busy as possible. Throughput. Throughput is the number of processes that complete their execution per time unit. Turnaround time, amount of time to execute a particular process. That is turnaround time. What time it takes? You sometimes say that process is taking a long time. Waiting time, amount of time it takes from when a request was submitted until the first response is proceeded. Our first response is produced. That is response time, when it gives some result. The criteria should keep in mind. What are the optimization criteria? Maximum CPU utilization, maximum throughput, minimum turnaround time, and minimum response time. Now, let us go to, I'm stopping for a few minutes. I want anyone to ask question. But since there is no question from your side, so I'm proceeding. These are scheduling algorithms. Multi-level queue scheduling, multi-level feedback scheduling. These I have kept in bold because there is certain difference. All these scheduling, they are not multi-level queue scheduling. The rest are first come, first serve, shortest job first, round priority scheduling, round robin scheduling. So these are different scheduling algorithms. This is first come, first serve. The shortest process, see, the process and burst time is given, and the process which have shortest burst time gets the CPU first. Here, the process that enters the CPU or that enters the queue first gets the CPU time. There are three processes, P1, P2, P3. Process P1 is having 24 minutes or 24 seconds at burst time. Process P1 is allocated burst time, then process P2, and then process P3. These are shown diagrammatically with the help of a chart which is called NAT chart. First come, first serve scheduling, how the average waiting time is calculated, that I will explain in next class because the time is lost. There are certain effects in FCFS that also I will explain. There are some advantages. Simplest form of disk scheduling algorithm. Easy to program, intrinsically fair. Disadvantage, waiting time can be large, and also it is not suitable for time sharing system. Now, FCFS scheduling, just remember that CPU is allocated to process just as they are coming.